introduction. One moment. There we go. Okay, well, thanks for the introduction, Pat. It seemed like, given what Ted and Pat were wanting to do a seminar this semester, that it might be a good opportunity for me to provide an update to the department about some of the bat work that I've had going on over the past few years, because we're kind of at a transition point with a first grad student having wrapped up and a second grad student about to wrap up at this specific study site that I'm working at with students, and then I have new folks that are coming on board. So it seemed like it would be a good opportunity to kind of go over some of the work that my lab's been doing related to Indiana bats at a specific wildlife management area in Scott County, Kentucky. So there we go. So just to sort of point out the folks whose work I'll be really synthesizing and just hitting the high points on here, I'll point arrows out to a handful of folks on this slide. Specifically, I'll be providing overviews of the work that Reed Crawford, there on the left, Elizabeth Robinson, immediately adjacent to Reed, and then Michaela Rogers to the right on the image, that they have been doing over the past few years. And so it goes without saying that all of the information and the data and the core results that I'm presenting here are really, you know, it's the Reed and Michaela and Elizabeth show in terms of the bulk of materials, but also I'll hit on some of the results from Dalton Bundy, who was the most recent REU student that I worked with this summer, as well as at least give a nod to the direction that Shannon Howe will be taking things from here on out over the next couple of years with some telemetry work. So that's kind of the you know, individuals within the lab that I will be pointing out. Of course, there's other folks that don't have arrows pointing to their heads in this in this image. Courtney and Brittany and Sarah Baker and other folks that I'm working with. They're doing a variety of other projects, but you know, since I've been here at EKU, I've had a handful of different bat projects that have been going on. And if we're talking about the status of bats in North America, just as a general starter outer, it's worth at least acknowledging the widespread and continuing devastating impacts of white nose syndrome. So if you're wanting any authoritative information about this disease, I'll just go ahead and point you to the URL that's on the slide here. whitenosesyndrome.org is really the one-stop shop for all things white nose syndrome related. But you can see this is one of the most recent spread maps for the disease. There in Schoharie County, New York, there's the purple county that has the red circle. That's the epicenter of where white nose syndrome was at least first discovered way back when in 2006 and 2007. And since then, this disease, which is caused by a cold-loving yeast-type fungus, has basically traipsed its way down the spine of the Appalachians and northwards up into Maine and Canada. And you know, really about the time that it was hitting Tennessee and Kentucky, it started to move out westward also. And it's worth noting that the move of this disease is of course related to migration patterns of bats, but the bats that are specifically dying from white nose syndrome are cave hibernating species. And there's a wide variety of species that are suffering the ill effects of white nose syndrome, but one of them that's worth focusing on and getting has continued to get attention even long before white nose syndrome was an issue was the Indiana bat, because the Indiana bat has been listed as an endangered species for decades. And the Indiana bat is really one of the initial, I guess to pull a term that, that we were using before we started recording the seminar here, a poster child, if you will, for a species on the ESA. So the work that I'm focusing on here is specific to the Indiana bat, and more specific than just dealing with the Indiana bat. It's the work has really been focused on understanding use of artificial roost structures by this endangered species. Artificial roosts are becoming increasingly common as mitigation tools, and we're beginning to think of them more and more as a means of perhaps helping fight the good fight to keep healthy bat populations across North America. And so because of that, that's why a lot of the work that my lab's engaged in now is focused on this artificial roost issue. In terms of the funding for the projects that I'm talking about here, Kentucky Department of Fish and Wildlife funded essentially a Michaela Rogers project through the first 3 years of the window of time that I'm dealing with here. And more recently, Joy O'Keefe and myself have received a grant from the U.S. Fish and Wildlife Service through the White Nose Research Grant Program, and that will provide funding on paper through 2022. But of course, with the issues of COVID and with the information that the feds have provided to folks, 1-year extensions are obviously in the cards for most folks this past field season, given that field work wasn't necessarily possible, in a lot of capacity. So that's the principal funding for the work that I'm talking about here. But also, I've provided, I have been provided with a lot of help by the NSF REU program that we have in place here in our department, spearheaded by Dr. Brown and Dr. Richter in the first iteration, and more recently Dr. Brown and Dr. Watson in the second iteration of that REU program. So I've had a number of different REU students, and 2 of them have explicitly worked on the work that I'm talking about here. And then finally also, I've received one of those university funded scholarships, and that kind of kept Reed Crawford on payroll through the front half of, of a field season. So very, very thankful for that. Just to kind of flesh out why the study area that I'm focusing on with this talk is important, I'll show this map here. So this is just a range map for the Indiana bat. This comes from the feds, from the U.S. Fish and Wildlife Service, and this is specifically the Midwestern regions, like a range map. And you can see the little red explosion mark that I have there in northern Kentucky. That's Scott County-ish. That's at least that bubble includes Scott County. And really, it's right in the heart of the distribution of the Indiana bat. So, here in Kentucky, we have many important hibernacula and maternity sites for this endangered species. A lot of bats hibernate in Kentucky and then will migrate away, and then they bounce back again, back and forth, back and forth. So Kentucky generally is an important place for Indiana bats, and there's a strong history of doing Indiana bat research, in our state. But more recently, since about 2016, 2017, there's been a focus by Kentucky Department of Fish and Wildlife to be doing a bit of work at this location in Scott County. So Veterans Memorial Wildlife Management Area is about 2,500 acres or 1,000 hectares, thereabouts. It's immediately on the east side of the interstate. If you hit the exit for, I think it's Cherry Blossom Way, exit 129, there in, as you're coming through Scott County and as you pass through Georgetown, immediately, if you just start looking on your right, you're going to be passing by this wildlife management area. It's really easy in terms of a lot of the access for this site, because we have just a north-south highway, or not highway, but the highway corridor to the west is a clear boundary, but the actual interior of let me go ahead and use a highlighter. The interior of the site is really accessible by this north-south dirt road that gets you in and out of the location. So it really is a pretty great place to be able to do some field work, sort of working through here. Okay, and so this site, it's in northern Kentucky. It's, you know, it's within the heart of the bluegrass. There's loads of game species here. There's a lot of managed open habitats. As a consequence, there's a load of hunters. There's a load of humans on site. So that is something that we do have to wrestle with. But it also has loads of Indiana bats, okay? And that's, of course, why we're using it as a field site. Here's a good representation of what the field site looks like. You can see it's kind of the classic, like, lush green hill with a lot of understory veg, and then overstory. This is kind of a slough area that you're seeing through here. It's pretty wet, which Indiana bats tend to like. There's a lot of shagbark hickory, which Indiana bats like, but also there are a variety of artificial roosts that have been in place for a number of years that were put in place to provide roost habitat for this species, and also to it provides an easy way to kind of keep your eyes on this species. It's, you know, in a lot of ways, Zach Couch, who's the at-risk species biologist for Kentucky Department of Fish and Wildlife, he sometimes will jokingly refer to these artificial roosts almost as if they're like pieces of tin that you would use for surveying for, you know, for snakes. You put out any of those types of old bits of tin on the side of the road, and you can come back and check them periodically. You put up roosts like this, and the bats, they really like them. So that's part of the reason for the locations of these roosts. Here's another representative image, and of course you can see that telephone pole that has the roosting material sort of lashed around it up at the top. It's adjacent to this relatively large pond that's at the area. There's a mix of open and wooded habitats, and again, Indiana bats are really prone to be found in this area, and there's been a maternity population on the ground for years, and it has been studied over a number of more recent years. So with that in mind, I'll go ahead and sort of move over to Michaela Rogers' thesis research. And so what I'm going to do for Michaela and for Reed is really just provide kind of a summary of the core chapter topics, because I don't want to necessarily steal Michaela's thunder, because she's going to be defending in a few weeks. And many of you saw Reed's exit seminar earlier this year, so I don't want to just regurgitate that material. I just want to hit on the high points and kind of illustrate how all of these projects are interrelated to one another. So Michaela's core thesis topic is really seeking to understand the potential white nose impacts that might be experienced sort of at the reproductive level for Indiana bats in Kentucky. As I said, they've been endangered for decades. White nose syndrome is really a double whammy on these species. And so we don't necessarily know if the adult bats that are still persisting in the face of white nose syndrome are capable of reproduction, and to what degree their reproduction almost at the population level is going to be suitable to recover the species. So that's the A1 objective of her thesis research. But additionally, with all of the netting that we were doing, we were able to get some really great recapture data for Indiana bats. And finally, given the fact that these bats are using these artificial roosts, we're in a position where we can look at sort of temperature conditions. And really what Michaela started out with her project focused on these Brandenbark roosts, Reed Crawford was able to take a step further with some novel roosts on the landscape to sort of like provide choices for the bats to see how roost selection may play out, okay? So in terms of Michaela's research, she's not just working at that Veterans Memorial Wildlife Management area. That is the focus of this talk. There are two other sites that she's focused on. One is in Bullitt County, and I love this acronym. It cracks me up every time I see it, but BARF is Bernheim, the Bernheim Arboretum, and I think it's Research Forest, but that's our acronym for Bernheim. And then also there's a WMA out in Breckinridge County where there's a number of these artificial roosts deployed. And so those are some of the most heavily surveyed and monitored and researched maternity locations for the Indiana bat in the state of Kentucky. And because Michaela Rogers is a biologist with Kentucky Department of Fish and Wildlife, you know, she was already sort of plugged into the work related to this thesis project. And these were the natural, logical places for us to assess these population level, like reproductive impacts. So with Michaela's principal sort of focal chapter, what we have done over the past 3 years, so we started in 17 and then 18 and 19, we had 3 maternity seasons where we would visit these Brandenbark Roosts. And so let's see here, you can see these poles. What's happened here is we've essentially partitioned off or put mist nets all around this central artificial roost. And I haven't explicitly explained it just yet, but what these Brandenbark Roosts are basically electric or telephone pole type material that's been dropped into the ground. And so at a height of about 20 to 25 feet, you have artificial vulcanized rubber that mimics bark. And so that 1 to 1.5 meter length of false bark covers the top of the pole, and it basically acts as an analog for like exfoliating bark that you would see on a dead or dying snag on the landscape, or perhaps like shagbark hickory or another roost tree that Indiana bats like to use. So for this project, we targeted these artificial roosts. We put mist nets up. We did this over a very concentrated window of time. We were looking at what was going on in the maternity season, and we captured the bats and we measured them, and we developed an overall sort of assessment of reproductive health. And so I'm going to leave the results of that to Michaela. She'll talk about that here in a few weeks. But just in terms of other components of her thesis, you know, we conducted 22 mistnet surveys over those 3 years. I'll just point out this is the deepest I'm going to go with results with Michaela's work. We caught over 800 Indiana bats, and we had over 100 recaptures. That's a high number of captures, and that's a high number of recaptures. And this is good information, given that Kentucky Department of Fish and Wildlife wants you to ban these Myotis bats, and specifically these Indiana bats. So that little band that you see on the wing allows us to get an idea of when and how we're when and how and where we're recapturing these bats. So that's sort of a happy extra item related to Michaela's thesis. And then as a final thing, you may have noticed, at least on a handful of these Brandenbark slides, there's these weird sort of structures on either side of the Brandenbark. If you're not familiar with these, those are radiation shields for like a hobo data logger. So you can use hobo data loggers in a variety of contexts, but if you put a temperature sensor out in the middle of the blazing sun, it'll get hotter than the actual ambient temperature. So that's actually like a solar shield to cut down on, you know, the direct sun and to provide an opportunity. The data logger's inside there where it can get a more effective assessment of temperature. So Michaela was able to collect temperature data on these roosts. Now, these roosts were already being used by Indiana bats, and we didn't want to have issues with take. So working with U.S. Fish and Wildlife, we basically were able to get permission to install these data loggers on the outsides of the roost as opposed to the inside during the off season before bats actually arrived. And so that's how we're going to be able to draw some inferences about perhaps differential use of these roosts related to temperature profiles, right? So those are the 3 sort of angles of Michaela's research. I'll point out that her defense is on October 23rd. It's bright and early at 8 a.m. This is going to conflict with at least a handful of grad students taking stats, but we tried to work around and come up with a date that would work, of course, with her committee and with everyone else that could be in attendance. And I'll just, you know, say, you know, like Mia Wallace says, you know, be cool, Daddy-O, and hope you can be there because you don't want to be a square. It'll be a really good talk, and hopefully folks can show up to that. Okay, so that's kind of like the first iteration of the research that was put on the ground out at Veterans. But Reed Crawford came along about a year after Michaela was getting into her thesis research, and we developed a subsequent artificial roost project that we were able to put on the ground. And essentially, we built a handful of new roosts. This is the classic rocket box roost design that's used all across the United States. And we were able to develop a variety of different box types or variants as compared to a reference model, and to look at Indiana bat selection of these roosts. And we have addressed selection on the basis of solar exposure and weather. And then on top of that, because we're able to actually get some temperature sensitive data loggers inside of these boxes, as they were being built, we were able to assess microclimates on the interiors of the boxes, which is a nice sort of addition to the type of groundwork material that Michaela laid out with her thesis research. Okay, so with this project, Reed basically had a heavy first field season, or I should say before he even got in the field, he had a heavy first year of graduate school building 40 rocket boxes. And each of these rocket boxes are on 4x4 poles that are 12 feet in length. And you can see there the overall length of that box relative to the length of the pole. These are big, these are heavy, and he built 40 of them. It's pretty crazy. The genesis of this project, though, really is attributable to, like Reed and myself were really standing on the shoulders of some of the previous work that Joy O'Keefe's lab did. And indeed, Reed was one of Joy O'Keefe's students at Indiana State University as an undergrad. And because Joy and I have known each other in the bat world, we're both, active biologists here in the East. We've been in communication. And so between talks with her and I, we kind of cooked up a situation where Reed was really well suited for this project and we needed replication. So I'll get into that here in a minute. But what we wanted to do was take a sort of proof of concept study and take it out and do a field deployed version. So Frank Tillman, who's shown here in this slide, he is one of Joy's most recent master's students that graduated from ISU. And in essence, Frank Tillman's project was he devised 20 different rocket box variants. So he manipulated the structures of these rocket boxes 20 different ways, and he deployed all of them in a very centralized location, and he had data loggers within these rocket boxes. So he characterized the microclimates within these rocket boxes with bats not using the boxes. So the idea was, of all of the different rocket box designs that you could come up with, what would be the best? And so Reed's project was then taking, of the 20, what were the 4 best that we thought would work for a field deployment, and comparing them to a reference. So that's what Reed did. So he basically scaled up the most promising box designs that Frank was able to develop. And just to kind of put things a little bit clearly here, so we're looking at the interior of a box. Each of those spots is an I button temperature sensor, right? So you're seeing one side of a box here. These boxes were arranged on the landscape so that they had a north, south, east, west sort of cardinal angle arrangement of 12 I buttons per box. And then we had 20 boxes per site. And then we had 2 different field sites, which I'm building up to. All of that is to say we had 240 something I buttons out recording data across an entire growing season. So a crazy amount of temperature data that we were collecting. But that's the locations of those temperature sensors, and they're replicated 12 per box. We had to take those boxes, we had to go dig in the snow before the field season of 2019. This picture here, I hope you can see the smiles. That's Reed there. That's Joy O'Keefe, my collaborator. That's me with my silly hat. We have Frank Tillman over here, and then that's Evan Mosier, who's an undergrad that worked in my lab over a bit of time. And honestly, this was one of the hardest weeks of field work that I've ever experienced. We had to get the skid steer and dig 20 holes in the bluegrass, and that was not easy in and of itself. And then we had to install these boxes and cement them in the ground, basically in the winter, in the early spring. It was pretty intense, but we did this not only at Veterans, but also at the Indianapolis Airport mitigation site, which I think is in Vigo County there. And so you can see the relative sort of position of the other field site. But I would just stress, you know, this work that Reed and I did was really building on the foundation that Joy has established over years of her lab, right? Like she has a sequence of 3 or 4 grad students and iterations of undergrads that have built up to where we were able to get with Reed's project, looking at bat selection and microclimate variation sort of across a variety of landscape positions and box designs. So here's the relative placements of clusters of bat boxes. You can see those black dots. I'll just point out that basically we had boxes deployed in the open, boxes deployed in a heavily forested area, and then boxes that were either deployed on a western or eastern forest edge. Okay, so that's our design, and then we had it replicated across the 2 sites. And so ultimately, this is what a very clean representation of our study design looked like. This is 1 rep. So here you're seeing a cluster of the 5 boxes out in the open, and there's a weather station out there to the side too. We had weather stations at all of the different locations. So in terms of assessing how Indiana bats are using these different roosts, basically the entirety of 2019, and this actually carried over in this past field season as well, we conducted spotlight checks every other day. We also conducted emergence counts at the roosts that had the most bats, so we're able to get an index of use across the field season. And the main takeaways from this first chapter of Reed's thesis was that bats tended, at least in the first year, to select roosts based on landscape position and not design type. So regardless of box design, the bats didn't care so much about that. They tended to actually want to select boxes more on the basis of where they were positioned on the landscape. And in very simple terms, early in the season, bats used the forested clusters, and then they moved to a mix of using the eastern and western edge forest clusters, and they did not use the open roost clusters. So that just stresses the need to, have boxes in a variety of different conditions. And of course, this begs the question of what would happen in subsequent field seasons. Reed wrapped up his master's, but really the work that we're doing now is carrying on this work to really understand how bats might be fine-tuning their selection in subsequent field seasons. Okay, and so in terms of Reed's second chapter, he also looked at the microclimates within these artificial roosts. And forgive me, I know that there's abbreviations up here, but I just couldn't fit all of the text on the slides. The important thing to know here is that there's a reference design, and that's the standard rocket box. But then we had a couple designs that were designed in such a way that we wanted to minimize maximum temperatures of the roost. And then we had 2 designs that we wanted to make sure that we were increasing minimum temperatures of the roost. So we were seeking designs that tried to make for more stability of a roost. So we were looking to decrease maximum temperatures or increase minimum temperatures. Okay, and so I'll talk a little bit more of the designs here as I get into a couple slides, but that's the gist. And we had all of these boxes replicated across the landscape in a variety of landscape positions. And with that temperature data that Reed was measuring, we were measuring overall variability of temperature over the course of a day, right? So like on the right, this is one of Reed's like most clever figures that he used in his exit seminar. But within a box, you could have a maximum daytime temperature of 38 degrees and a minimum nighttime temperature of 20 degrees. That's an 18-degree temperature swing. That's the variability that a box experienced. But we can also look at the overall availability of temperatures within a box, right? Because these boxes are vertical structures. There's variation in the temperature gradient. So on the left there, we have availability. At any given time, a box might be at a temperature of 38 degrees at the top and 32 degrees down low. So there's potentially like a 6-degree window in which the bats could select, because they can move themselves around in the interior of this box. That's one of the cool things about a rocket box or a Brandenbark roost as compared to one of those classic like birdhouse kind of design boxes. In this situation, bats are able to move themselves around the roost almost like they're moving around, you know, the interior of like a piece of sloughing bark, and they're able to go higher and lower and potentially sort of like optimize the microclimate that they need at any given hour of the day. Okay, so the main takeaways from Reed's microclimate chapter was that landscape position did influence overheating risk, and as you would expect, being out in the open, boxes tended to get hotter, and in the forest, boxes didn't get as hot, right? And so if we look at overheating events, there's numbers that we can apply there. We did see some differences, and some roost designs were more stable, specifically our design that we called the exterior jacket. We built water jackets around one of the designs, and they were so heavy and so unwieldy, but the bats really did tend to like them. That they're more stable temperature-wise. Also, that WTR, that stands for white tile roof. Basically, we took a piece of like porcelain tile like you would use for a bathroom or something, and we stuck that on the top to reflect heat. And then the final one is CH, that's chimney. And so in this image, you're seeing that box that's all the way to the right. We built a chimney sticking out the top to let heat escape, right? And so those roosts tended to be more stable than the reference and the vent removal design. And then otherwise, another important takeaway is in this case, we were actually looking at roost use. So we were able to see that bats in larger groups had a strong positive impact on internal roost temperature. So basically bats and the numbers of bats within a roost can manipulate the temperature or influence the temperature of a box. And that's a really interesting deep dark well that needs to be investigated further to kind of know that interaction. Okay, so those are the two thesis projects that that have been going on out at Veterans, but I also want to take just a few minutes and talk about some of the undergraduate work that's been going on out at the site as well. I'll start, and I'll go through this chronologically. I'll start with Elizabeth's work. So Elizabeth Robinson was an undergrad here at EKU. She's since graduated, but some of y'all might remember Elizabeth. She did a sequence of 598. She did 2 of them with me, and she also did an RAU in relation to EKU's disturbance ecology and Central Appalachia RAU experience. And so with Elizabeth's work, you know, I was lucky enough to have a really invested rockstar undergrad that was able to work across a couple years with myself and Reed, and totally Reed should get the props here for being as influential and as important a mentor with Elizabeth as I was, just because he was there with her, you know, on the day-to-day. So Elizabeth was basically Reed's, you know, right-hand woman out there helping out with the emergence counts and the spotlight checks that needed to be done. But on top of that, let's see here. One moment. I'm gonna make sure. Well, I guess I omitted it because I put this slideshow together in the last 24 hours. I'll just go ahead and talk about it here. So looking at this slide, you can see Elizabeth's looking up to the top of the Brandenbark Roost, as it were, but there at the base, there's a frame of PVC. So one of the cool things that Elizabeth was able to do early on was devise a really functional, really cheap, standardized trap for collecting guano at these roosts. And that's something that is sorely lacking within the bat world. People do these types of guano collections at artificial roost and at natural roost, but you need something standardized, right? So that you're capturing or you're collecting poop from a given area. So that's what Elizabeth did. And so I seem to have deleted the slide that shows Elizabeth's design for her so-called $15 guano trap, because that's basically what it cost us to build to build about 36 of these things. We were able to build like 36 of them all for 15 bucks a piece and put them out. And so we're using those in my lab now to get standardized guano collection. So one of the take-home points from her REU was that there's a pretty clear correlation between the amount of poop that you can collect at one of these traps versus the bats that emerge from the roost. That makes sense. We're not dealing with rocket science here, but it's something that's really important for us to know. And it's something that's lacking out there in the literature. And so with this, you can see sort of differences between the two different roost types that Elizabeth was studying. And of course, there's some noise out once you get to more and more bats out exiting a roost. But if we zoom in and we look at specifically at these novel rocket boxes on the landscape, there's a pretty clear relationship between poop rates and bats that are leaving the roost. And so that's a really useful bit of information. And we were able to work that into the continuing funded work that's carrying on now into the coming years, okay? And so, yeah, Elizabeth was able to get at least a handful of different posters out of her work, and we were able to get that technical report for the $15 guano trap published in Bat Research News, which is a small peer-reviewed outlet for bat biologists. And yeah, it was a real success story. I was glad that we were able to put together something so functional and be able to work off of. And that's really, I think, a good segue into this most recent field season with Dalton. So Dalton Bundy was the second REU student that worked out at Veterans. And so Dalton wanted to assess a couple different topics. He was interested in getting some camera trapping experience. He really wanted to get some bats in the hand experience, and for reasons that I'll explain here in a few minutes, that wasn't quite possible. So in Dalton's case, we devised a couple different projects to kind of get him a variety of experiences. Unfortunately, I don't have, this is like the only picture I have of Dalton, so he's like suited up with an N95 mask in the dark. This is the one bat that he had a chance to hold. This is my only good picture of Dalton really that I have, and you don't see too much other than his eyes. He's piercing, his piercing gaze at the camera. But Dalton, his main focus was really, what I was really excited for him to take a shine to, was to basically do some camera trapping of the roosts themselves, because we're putting out these guano traps, and of course, we don't know if the accumulation of poop might be something that attracts predators, and we don't know the overall sort of incidence of predators visiting artificial roosts. So for Dalton's project, he had basically camera trapping in tandem to some of these artificial roosts that had guano traps or did not, and we didn't see any differences between predator visitation between roosts with or without a guano trap, and more to the point, we had very low visitation by mammalian mesopredators, things like raccoons or possums that we would suspect that might be visiting these roosts and potentially disrupting bats. So here, this bar chart that you see, this stacked sort of bar chart, that's the total image records that Dalton collected across all of his different roosts that he was surveying. He had 6 roosts, but he monitored them continuously over the course of the REU. And we saw very low incidence of mesopredators on these cameras just generally. We saw a variety of other things. That other mammal category includes a lot of squirrels and a lot of deer that just happen to be wandering around, right? But there was a relatively low visitation of either mesopredators or raptors, which were the predators that we were potentially worried about at these roosts. So this is useful information to have, and I'm unaware of anybody else that's really done anything like this. So if in the future, I mean, I hope this might be something that we can write up for, again, that Bat Research News, like a technical report for that journal, just because it's useful information to have, because of course it's something that we should be worried about. We don't want to be doing things on the landscape that are adversely impacting these already endangered species. Okay, the other component of Dalton's research that I'm glad that he was able to take a stab at was to actually do some acoustics work out on the landscape there at Veterans. And so up to this point, our work has been netting and artificial roosts. It's been very focused on Indiana bats, and we haven't collected any data on the other bats at the site. And we didn't really have an idea of how Indiana bats or other bats might be foraging and using the larger WMA area. So Dalton's laid the groundwork and did some acoustic surveys. So we have some data at this point that would be suitable for Kentucky Department of Fish and Wildlife to, use for their own reporting about species presence. And of course, as we would expect, the bats really do like the lake or that large pond that I showed earlier in terms of foraging. But this gives us sort of points to move forward if we're looking at any future studies that would be investigating the foraging habitats of bats at this site. Okay, so with that, we're really kind of getting up to speed. So here, I would point out that this morning I didn't have pictures of Shannon or JP, so I sent them both texts and I said, hey, send me a picture of yourselves. JP, I think he took this morning and he said, I hope this is fine. And I just kind of laughed because I don't know if he had a hard week or this is his level of enthusiasm this morning, but regardless, there on the right, that's JP Lyons. He's an undergrad in our department, and he's been an undergrad working on this project for the past summer. So he was Reed Crawford's helper, and more recently, he's been Shannon's helper because basically Reed wrapped up his thesis in the spring. He stayed on and worked as the lead, like the crew chief throughout the summer. And now Reed is pursuing his PhD at Urbana-Champaign with Joy O'Keefe. And so he has jumped right into that PhD, and sort of the day after that Reed left, I needed someone that could keep the Roost surveys carrying on for a week or two, and JP was trained up and he's really been great. So he was able to keep things going. And then Shannon showed up, right concurrent with the start of classes. And so Shannon Howe is an incoming grad student in my lab who will be taking over the reins at this point moving forward with a lot of the field work, sort of carving out her thesis within the larger project that we have, in place here, okay? So where we're going from here, this is the statement within the proposal that Joy and I have funded with the U.S. Fish and Wildlife Service. Basically, there's 2 points that we want to carry on. The first thing that we would like to do is see how selection and roost use changes over multiple successive years, because we really only have 1 year's worth of roost selection data for those rocket boxes that we installed, and we need to know how the bats are using them, right? So that's one objective, and we're doing that through a variety of methods that I've already outlined here. Guano accumulation through the guano traps that Elizabeth kind of refined, the spotlight checks and the exit surveys that Joy's lab have used over the years out at the Indianapolis airport site and works well, and that we've been doing here at VETS for the past couple years. So in those cases, we're going to be able to continually see how bats use and choose the roosts at those 2 field sites. But the new thing that I'm really excited about, and also it's a little bit scary to think about sort of ramping up to this level of how intense things could get, but we really need this kind of data. It would be interesting to know how the actual thermoregulatory patterns and profiles of bats might vary according to the roost that they choose for the day, right? So what we are doing moving forward is we will be netting bats in the relative vicinities of these artificial roosts. We're going to apply radio transmitters to those bats. The radio transmitters that we're applying are temperature sensitive, so they actually, through the variable pulse rate that they bounce back whenever you're picking up the data, with your telemetry gear, they can give you the temperature, the skin temperature of the bat. And moreover, you can use passive data logging telemetry receivers to continuously record that data. So don't necessarily have it as the next slide in sequence, but I'm going to go ahead and jump back. So within our 2 field sites, we have these clusters of boxes. Basically what we're doing is we're putting these low-tech data logging receivers in such a way that they will record data in the open cluster, and then the east and the west edge clusters, and then the forest cluster. So we have 4 data logging receivers that will be able to run over the entirety that we would have a transmitter active on a bat. And we have an extra sort of a mobile unit that we'll be able to use. So when bats hopefully are choosing novel and natural, like I shouldn't say novel, natural roosts on the landscape, we'll be able to track them in that morning, put the low-tech receiver out and collect temperature profiles of bats in natural roosts in that case, right? So of course, COVID threw monkey wrenches in everything fieldwork related this past year. Specific to bats, there was a moratorium on capturing bats. It looked like it was going to be throughout the entire field season because of the close relationship between bats and COVID in humans. Not only were we worried about like all the various pathways for transmission, we did not want to be in a position where we would be potentially infecting bats with the coronavirus this field season. So because of that, all across the United States, bat netting was on hiatus basically until July. The U.S. Fish and Wildlife and the federal government did a series of assays and tests, and ultimately researchers and consultants and state and federal biologists were then given the go-ahead that netting could commence. But at that point in time, it was July. So really what we did this field season, we were intending on getting like 9 transmitters out. We got 1 out, but I'm still counting it a success because we at least know that the system that we proposed in the funding source really does work. So here's an sort of a brief explanation of how we're doing things. So we have a triple high mist netting system. You can see that here, and then also here. That's the net. Here you can see one of the clusters of rocket boxes, about 40, 50 meters away. So we would net at a location like that. We had one night where we netted and we were successful. So here we have close to dark. Here we have one of the Indiana bats. We caught many Indiana bats that night, more than enough that we were able to find one suitably heavy enough to apply a transmitter. So we were able to get one transmitter out and collect data. And so we tagged a single juvenile male this past field season in July. We tracked that bat for a total of 12 days, which is great. That's kind of the expectation for the transmitters, having the transmitter work that long and having the actual glue, the surgical glue that sticks the transmitter to the bat's back to have it last 12 days, that's great. And moreover, we were able to use our data loggers and collect 10 days worth of data on this bat. The bat switched roosts 4 different times and used both a rocket box on the first day and then a subsequent series of different Brandenbark roosts. So this image that I showed before, this was one of the bat's roosts. So I tracked the bat and it was just here in this roost. The place that we netted is kind of back around the pond and up the hill, and it's not very far. It's only about half a kilometer away. So this field site could be really conducive to the future efforts. Like it's hopefully going to be pretty easy to get around, and hopefully the bats are going to stick fairly close to all of these various roosts that are available to them. So we'll be able to get this data like we're intending. As far as going on forward, Shannon's in a position where we have clear methods written up for what's going down with the roost selection related to the artificial roost. But the question looms: what happens when the bats choose natural roost? That's really that's Shannon's at least a portion of her thesis. She's developing some materials right now for Gary's writing class. That's kind of the lit review related to the natural roost selection type stuff. But beyond that, we'll develop at least another chapter or 2 for her that'll flesh out the picture of the telemetry type work that we're doing at least over the next couple field seasons. So that's really the status of a lot of the bat work that's going on in my lab. I'll just point out that there's other folks here, I mentioned it before, that are doing non-bat work or doing bat work but unaffiliated with the veteran site. And I would be remiss if I didn't, quickly mention them. So of course, most of y'all probably recognize Dr. Watson. She's over in geosciences, but Kelly and I collaborate on a variety of projects. We're co-advising Courtney Hayes, who's a biologist with Nature Preserves, and is currently writing up her thesis work related to eastern spotted skunks and mesopredators in eastern Kentucky. Over the summer before this past one, so I guess this would be what, summer of 19, Brittany Ryan was the REU student that Kelly was the principal advisor for Brittany, but I helped out too, and we did some bat work on the Daniel Boone wetland system that Kelly and Malzone and Richter have worked on over the years, and many other people, of course, right? But doing some bat work there, and then also Sarah Baker is another new grad student in my lab, and so Sarah is going to be doing nature preserves and something small mammal-y, and it will be a fun sort of bit of variety, in addition to the bat work that I talked about here today. So that's all I got. Thank you all for listening. Sorry that the slides were a little bit disjunct and I had a couple things missing, but that's what happens when you put a slideshow together in the last day before it's due. So something to pay attention to, grad students, hint, hint, hint. I'll take any questions.
Luke, thank you much for a great presentation and a great overview of your actual research efforts. Much appreciated. Folks, we may try something different. So if you go out of full screen and go down to participants, and you can then, that's right. Yeah, you can then, I believe, raise your hand. So I'll try and, if you could, raise your hand in the participants room, and I'll then try and call upon folks. Or if I don't see you, just holler out then. But questions for Luke about his research efforts or about his seminar today, or comments?
There's crickets chirping.
Luke, you mentioned that many of the bats seem to prefer moist habitats where there's some water. Is that more for foraging purposes? That there are more insects out there, for example?
Well, with Indiana bats, I mean, they are like the images that I showed here in this, for the site. That's like, that is pretty classic Indiana bat habitat throughout much of the Midwest. And the other site that Michaela is sampling in Breckinridge County is another sort of like prototypical like Indiana bat site, in that it's like a lot of sloughs and a lot of bottomland kind of conditions with some really sort of hairy, like early successional habitat next door. Indiana bats like edges, and they like those aquatic habitats. They're not necessarily like a riparian specialist by any means. There are other Myotis bats that fit that bill a little bit more closely, but Indiana bats do really like water, but they're pretty opportunistic in the habitats that they'll use, like because they're just so widely distributed. So bats do like riparian areas on the basis of presumed prey abundance issues, but also on the basis of like the structural ease of foraging, right? It's edges and they can get around and they can work those kinds of areas.
Thanks. Ken, you got a question? Ken Blank?
Yeah, Luke, one of the things you were saying was the collection of the guana.
Mm-hmm.
Curious, has anybody actually studied the guana looking at pathogens or pathogens?
So that's a good question. So yes, and actually one of the things that we were doing this summer, because we're doing that routine guano collection, Joy has a couple collaborators that are really like steering the boat. One of the individuals, she's at Colorado State, and the other individual, she's at Indiana State. They're doing some pathogen coronavirus type sampling. So we collected like 10 or 12 different samples throughout the field season, like on bi-weekly periods. Like basically we just aliquoted out a portion of our poop that we were collecting for that. So that is something that I know there's at least one project that got kicked up this field season that's looking to do that sort of distribution wide for Indiana bats specifically, because I know that Joy and her collaborators were looking to get the Georgia DNR folks involved as well as the Indiana folks involved. Like they're looking to do sort of distribution wide. So I don't know any more specifics than that, but that's the kind of thing that, of course, a lot of people are looking at right now.
Dr. Brown.
Hey, Luke, I'm wondering from kind of the perspective of like studying entire populations or kind of across the range of these species, not just Indiana bats, I guess, but any bat that's affected by white nose syndrome. How do you go about untangling the effects of white nose syndrome and just overall declines in insect populations? Because either one of those things could theoretically kind of drive populations down and probably are contributing to declines. But how do you separate out the relative importance of those?
So I didn't say it explicitly, but Michaela is taking some of the previous Indiana bat records for the state, and she'll try to look at like data before her project versus her current project having bats in the hand for that kind of comparison. So she's using like that type of data, and that might give at least a little bit of an indication of like longer term population level trajectories for the Indiana bat. And I know that's not exactly what you're asking about, but you know, like having a deeper sort of like time series of data would be useful for answering that. But really, like outside of having good insect data alongside the bat data that you're collecting, like it would be hard to say that. So we need to do that. And at least, you know, with the work that I did out at Mammoth Cave, a lot of that was just as much a entomological focused project as a bat project. I haven't been able to plug that in with this project yet, just because the money and the time and the effort has been focused on the bats, but that's something that we need to be mindful of. So outside of having measurable insect data that you can overlay with the bat data, I don't see an easy way to answer that question.
Well, what about species of bats that aren't affected as much by white nose syndrome, or parts of the world where it hasn't had an impact as much? Are bats showing similar declines?
So yeah, so I mean, yeah, so people are looking at that, but all, you know, I guess thinking along those lines, like there are at this point lines of evidence that are not just showing negative impacts of white nose on bats, but in some instances, like with evening bats, like that's a species that at least my old advisor at UK, Mike Lackey, he has a student or two that have papers that show at Mammoth Cave, like evening bats have increased over the years, kind of coincident with white nose on the landscape. And so that's kind of something that's not just anecdotal. There's evidence out there that like certain less or not white nose affected species are changing in their overall patterns of activity. And definitely with the acoustics data that like Rachel Griffiths did with my lab, like my first grad student, she showed pretty dramatic increases in tree bat, like Laziurus genus, like coincident with white nose arriving at Mammoth Cave. So we are seeing in some instances increases in like acoustics at sites, you know? And so the idea there is it's loss of bats that were filling niches and like niche expansion type stuff. But like the long-term big insect declines you're talking about, I don't necessarily see an easy like solution just that's United States focused. I think your idea of like looking at European and maybe other whole Arctic bats, that could be a cool way to kind of get at it.
Luke, David, and Stephen, a thought comes to mind as a suggestion for the spring. I'm hearing all this cool REU work from your lab, Luke. It might be nice to have sort of a group seminar between doctors Brown, Richter, and Dodd, just highlighting some of the REU efforts that have gone on in the past. I guess we're in our second or third iteration of the effort. Might be nice to have a general seminar about look what's going on with REU efforts here at EKU in terms of different projects. So
yeah, I mean, there's been so many folks that have had students that they've mentored, and you know, I'm not just there's been a variety of folks that have mentored students across seasons too, right, David?
Yeah.
Yeah, I'd say it'd be good to have. We could, since we're on Zoom, we could invite those REU students to give a 15-minute presentation from their university for job.
Yeah, that'd be a cool idea, Stephen. Again, I think in terms of communication, I'm hearing really phenomenal things going on, and it might be nice at some point for, if I can put it up on you guys, the three of you to sort of get together, as Stephen says, maybe a Zoom, and have folks just say, this is what we've done here in the past. Because again, remember, folks, we're going to post these seminars onto our departmental YouTube channel, and so it's a great way to publicize to the administration. NSF, for example, look what we're doing with these efforts then. So, because this is all really, really cool stuff. So thank you, Stephen, for that suggestion. Wow.
Yeah, and we do have some RU students that are presenting this semester, like Nick worked with Jen Koslow, and then Deanna worked with Jen Koslow, and who else? Jenna Rubens, who worked with Dr. Malzone. So we have several of them presenting this semester, and we'll kind of continue to pull them in the spring. And yeah, maybe some kind of presentation that shows like all of it together would be cool to do.
David, I think so often we hide our lamp under a basket, to quote scripture, and it's like, yeah, let's let folks see what, I mean, and even ourselves, the cool things going on with our labs. Thank you, David. That's a great suggestion. Any further comments, folks, for Dr. Dodd?
Stephen's hiding his lamp in the basket.
Yeah.
Although that basket has holes in it, so I can see it still.
Oh.
I have a question. Sorry.
Please.
I have a question for you, Luke. So the Indiana bat, is it a specialist in terms of which insects it feeds on? Does it prefer moths or aquatic insects?
It is a bit more generalist. So if you're talking about bats that are outright sort of like specialists for specific groups of insects, really you here in the eastern United States are either talking about like big brown bats and evening bats. They're kind of like the serotine bats. That's kind of the generic kind of group that they're associated with. They're the beetle specialists. They're big skulls, heavy jaw muscles, and they can crunch a lot of beetles and true bugs. And then on the other end of things, the big-eared bats within the genus Corinnorhinus are moth specialists, and they're probably some of our best examples of like true blue, like specialists for moths. More broadly, moth specialization is something that people have argued. Like I have a paper from my postdoc stuff that was on the northern long-eared bat that looked at its use of Microlepidopteran moths, and that species of bat used a bit of moths. So I know that Joy O'Keefe, who I've mentioned previously a number of times in this talk, she was doing a diet project on Indiana bats doing molecular work, and so she's at least got one grad student that's plugging away on that. There's varying levels of specialization, but Indiana bats they're pretty general or like Catholic in their foraging habits in a lot of cases, and so while I think you could make some argument that they might be moth specialists, that's about as far as you would be able to take it. They're certainly not like dipteran specialists or beetle specialists. Like you don't really see that. It's if there's any one group that they tend to like, it's moths.
What time of the year do they typically, are they out feeding usually? Summer?
Yeah, here in Kentucky, really it does align with like the maternity season and sort of like maternity work. If you're a consultant that's catching Indiana bats, historically it was May 15th to August 15th, but it's been pushed back to June 1st, more on the basis of not wanting to have like adverse like land use impacts on Indiana bats. But really, parturition through like pregnancy, up through June, and the babies are being born at that point in time. So they are out and at a site that they would have been migrating from, by May for sure. Like that's when maternity colonies can start to form up. So if you were wanting to do sort of any sort of insect work, you know, to try to see if there might be impacts of bats on insects, that kind of thing, you really would be needing to survey insect populations in April so that you could see, you know, any sort of change in species turnover and population level impacts. So.
Thanks, Amy. Further questions for Dr. Dodd? Okay, folks, thank you for your time. Again, quick reminder to everyone, KAS abstracts due this coming Thursday, October 1st by midnight. We will have no seminar next Friday. We have Assurance of Learning Day. After next Friday, October 9th, I believe, we will begin our student presentations then, and Ted Brancho will be taking charge of that effort. So thank you all for your time. I really appreciate it. And we are recording all the questions and answers as per Dr. Richter's request, so we'll also have these in with the video. We'll upload this probably in about an hour or so, I think, to our departmental YouTube channel. Luke, thank you much. And
Yeah, thank you all.
be safe. Have a great weekend, folks.
Bye all.
Bye.
Thanks, Luke.
Yep. Thanks.